Hello, my name's Chris Leach. I'm the Manager for Europe for Geometrics, and in this series of tutorials what we're going to do is we're going to guide you through the process in easy steps from laying out our field acquisition equipment, planting the geophones, laying the cable, connecting up the geoseismograph, and then the processes involved in processing that data, which will include doing our first arrival picking on our field data, drawing out our time distance graphs, making any corrections to these that are necessary to eliminate bad data points, etc., any errors in our field geometry that we may have made, and then inverting the data to producing a finished section such as this, as we see on the screen here, which includes elevation information on the data.
This video tutorial is a follow-up from the field parameter setup that we've recorded earlier. At the moment what we're looking at is the boot up sequence of the Seismodule controller software as it runs through the digital checks when the computer software is talking to the geode. This first message that we get, we need to click on OK on this, otherwise you're going to end up with a very large file which you don't need. And we now come to the initial screen, which we're showing here at the top, the shot window, and this is where we'll see the seismic data that we acquire, the noise monitor window, and if I place my fingers on the input terminals of the geode, we can see noise variably appearing on some of the channels of the seismograph, which shows us that the instrument is basically working okay, and we're seeing data appearing, albeit temporarily. The next window down is what we call the log file. The geode creates a file of everything that you do during the day for its own internal purposes, but also for you for a useful quality control function at the end of the day, so you can tell what you did and when, what parameters you used to record the data, where the shots were recorded, etc., etc. At the bottom of the screen we see here the geometry toolbar, and here at the right hand side of the screen we can see the geode. Below it here we see the battery, which is currently displaying a voltage of 12.7 volts, so we have a healthy voltage on the battery. The geode in fact will operate down to about 11 volts, so we have plenty of power. The green triangles along here show the geophones and their respective positions. We have the geophone position and the geophone number, which is why we have the 1s, the 2s, the 3s, etc. repeated. And in the middle here we have a sledgehammer, which is relating to where the shot point is going to be. We'll now run through the setup parameters which you have to use to set up the geode software to record a basic seismic refraction spread. The first thing we need to do is go to the geometry window and check that our geophone positions are in the correct place. So we come here to geophone interval and we can select what our geophone interval is. At the moment it's 3 meters. If we're using feet as our units, we can change this to feet if we wish. Click on OK. It's just telling me a message there that I haven't actually changed anything. Now, if I have any geophones which are actually not at 3 meters, for example, if I had an obstruction in my seismic line, a wall or a ditch or a tree or something like this, then maybe I have to alter 1 or 2 of the geophone locations. Here I can go into this location and come here where it says geophone coordinate, and I can dial in, simply type in the new location for the geophone. Now I'm not changing anything at the moment, so I'll click on cancel. Once we have our geophone parameters and our shot point parameters entered in, I would now come to the acquisition menu here. If I click on this, the first thing we need to identify is the sample interval, which is number 1, and the record length. And here I will select a typical set of acquisition parameters which I would use for a refraction spread. Please note that the sample interval here is shown in microseconds or milliseconds, but when we come over to here to change the recording length, that it's shown in seconds. So I'm going to change this so it's now, our sample interval is 62.5 microseconds, and I'm going to change the recording length so that it's something like 1/4 of a second. At the moment we'll leave the delay to be 0. This relates to a more advanced parameter which is useful to know about when you have got a little more experience in setting up a refraction spread. At the moment we'll leave the delay to be 0 seconds. The next thing we'll look at is acquisition filters. The geode has got a range of data acquisition filters which will filter the data as it's being recorded. This is very useful if you're in an area with background noise which may be caused by wind or traffic or power line noise, for example. So if it's traffic typically is a low frequency signal, so I would select maybe a low cut filter of 10 or 15 Hertz. And then also if I'm near power lines, I will select a notch filter which will just take out the power line frequency. In the USA we'd select 60 Hertz, elsewhere in the world maybe a notch filter of 50 Hertz is applicable. So I've selected a low cut filter and a notch filter which will take out the low frequency noise typically from traffic, and the notch filter which is going to take out power line frequencies of 60 Hertz in this instance. We're now ready to take our first shot, but at the moment what we're waiting for is the status bar on the bottom of the screen here, which is green, which means that we're ready to shoot. If this is any other colour, then the geode will not trigger. Typically, if a parameter is being changed, for example if I come here and change a acquisition filter, it goes red. So at the moment the geode will not allow any trigger impulses at all. If I hit cancel, it'll go back to green. So when the status bar is green and down in the bottom left it says armed, then we're ready to trigger. Now what I'm going to do is, as we're not in the field, I'm going to play back a file from memory.